Today is Spygo's birthday. What did I just jump into here? Yeah, you're first. Happy birthday, Spygo. Glad you could join us. Well, what we're going to do today is sort of a lengthy procedure. So, what I'm going to be doing is I'm going to be cutting carbon fiber. I have got my respirator and everything, gloves. Um, Once I get these tubes cut down, I'm talking about these here, these 10 or 1,000 millimeter rods, which I have marked at the points that I need. I'm waiting for a couple of pieces to come off the printer, but they should be done pretty soon. I'll get a notification on those. And what we're going to end up doing is, well, basically, we're going to be assembling the body of this drone. And at one point, because of the way it has to be assembled, we're going to have to basically get the epoxy mixed and then get everything put together all at the same time. So it's going to be a bit of a challenge to get that done. But what I'm going to end up doing is raising the table here. I got one of those neat ones that goes up and down when I want it to. And then what we're going to end up doing is we're going to be starting on cutting and fitting. I got to get everything fit into the drone. We're going to swap the camera around so you can see what I'm doing, what's going on. And yeah, then we're going to go from there. So I'm kind of waiting for everyone to drop in, if anyone's going to drop in, because you know how it goes, right? I'm going to try and watch the chat as closely as I can, but when I get to the floor, what's going to end up happening is I won't be able to actually answer all the questions right off the bat, because I'll be down there working. I'll be watching the tab down there to see if I can answer them. It'll be on the same delay as everybody else because I'm watching it from my tablet. But so what we're going to get started here is I'm going to get the camera in position, and then we're going to get things going here. And I'm going to get this thing raised up because we have some work to do. Hopefully that doesn't pull anything off the table. All right. The table is moving. That should give you a clearer view of what we're doing. Okay, I don't think anything got pulled out. All right. Now we'll try and zoom it out a little. I don't know if I can. Well, I guess this is the 0.5. Is this what you're getting? Okay. All right, so what you're going to end up seeing is me down here cutting everything. Hola, ¿cómo estás? Welcome, Emily, to the chat. Today is a build day. So yeah, I'm going to be down here cutting this, and then we're going to get most of this put together. Now, part of what we have done already are these pieces here. So I have a couple of these pieces coming off of the printer, and these ends right here, because it gives me the ability to kind of slot everything in. And I needed to get, since this is the bottom of the drone here, I needed to get a little bit more carriage room for the battery pack. So what I did is develop these, and everything's going to get fiberglass anyway. All the connection points are going to get epoxied and then glassed over with fiberglass tape, and then we'll let it dry, set up for 24 hours, and then come back the next day and do it again. Because what will happen is once I get this bottom part finished, then I can flip the drone over and then do the fiberglass tape on the other side for all the joints and everything else. But this is going to be a bit of a process, so we'll get that started. this tablet should give me some indication of the chat. Hopefully. Space Marine, hi, how you doing? Glad you're here. I'm going to be on the same delay as you guys, so I apologize for that. I might be able to look up at the screen occasionally and see what's going on, but basically this is what we're doing. So we have a lot of, we ended up getting a lot of rods. So this is what we're reinforcing our body with right now. I'll wait for the ad to go by. Okay, so and there's a lot of these pieces here I'm going to pull back out of these older joints that I had made because I wanted to cut them in order so they had clearance for the top side of the body. So we'll be knocking those out, and we'll be basically doing everything we can to get this thing put together. Right? Okay. So what I'm going to do at this point is start cutting these rods right here. So I've got my Dremel and everything set up over there. I am going to have to put on the respirator, and I'll have to turn the vacuum on to pull up most of the carbon dust because we don't want that floating around here. So if I'm not chatting for a minute, it's because I'm working, and that's what you're here to watch. So let's get ready for that, huh? For all those who may be interested, you are watching the assembly of the largest fully 3D printed EDF drone so far in the world that I have seen. Everything from the blades to the ductwork to the stator, everything's 3D printed, the whole thing for the most part, except for the carbon fiber rods for reinforcement. But I mean, that's kind of a no-brainer. You kind of have to do that, especially since with the thrust I'm getting out of these motors. So let's go ahead and get this chat up so I can watch it. I'm doing good, Joe. How you doing? J-Bob, welcome to the chat. You just got a new printer. Which kind? What kind of printer do you get? The A1. That's a. Now, is there a difference between the A1 and the A1 Mini, or is the A1 the Mini? I never got that part. I got an X1 Carbon, so that's what I've been using to do all this. This all came off of the X1 Carbon. This entire printer, or this entire drone. Okay, so they got the A1 and the A1 Mini. Is that, am I hearing you correctly on that one? Or is the A1? Okay, I got you. Okay. I haven't purchased any more of their printers just yet, just because I'm seeing how far I can push this one. And in one of the last shorts, the funny part is there's a tube that comes off the back of the AMS. And because I had been printing so long, this took 28 kilograms of filament to print. So I've been printing for so long that it literally wore a hole through actually cut a groove through the tube coming out of the back of the AMS that goes into the printer. To where at one point I was putting in new filament. I hadn't noticed it. And I was putting in new filament, and when it tried to spool it in to identify it, the filament came out of the top of the printer from the back of the AMS and went towards the ceiling. And I was like, well, that's not right. So I checked it, and I realized I wore right through that tube. Just so much printing and pulling from the AMS just wore a hole straight through that tube. It's just a long 2-inch groove where it finally broke through just from the friction of the filament going through that tube. It was something I'd never seen before. So yeah, that was fun. So what we're going to do now is I'm going to mess up my hair. Put on my respirator. Oh. If I can get this thing on properly. All right, clip on there. Ugh, okay. See? All right. Now, gotta get some gloves on. I'm getting gloves on because of the carbon fiber. The way I have to cut it is going to be with this Dremel. I don't have a saw. I need to get a saw so I can cut this stuff. Use the force. All right. Okay. When was your last exam? All right, here we go. Now remember, if I can't hear your chats or if I don't see your chats right away, I will get to them. Hold on, somebody said something. Fusion 360. That's what I designed it on. All right. This is probably going to get a little noisy, just so you know. But I already have my marks are already cut. So now, the fun part. Okay. Oh. Whew. Well, that's the first two. Oh, my goodness. These will always be saved for other parts, other projects, so on and so forth. So these are my leftovers, but I'm going to be building all kinds of other stuff. So. All right. So the idea behind that, let's take these inserts that I showed you I created. Now these top or bottom? Top or bottom? I think these are bottom. Yeah. You want to get that in there on the bottom, which is actually the top. These will go straight in. I don't have to worry about these not fitting or being too far up. So we'll have these rotators here on the next two that I cut, and that'll give me a chance to move things to whatever gate that I need, and then I can rotate these and they'll go against each other. So what that'll end up doing for me is giving me a center area that I can adjust, and I can set it to where everything's connecting. So when these cross, I can fiberglass tape those. Then basically the whole thing gets reinforced. Then my battery deck will be up under here, and obviously the flight deck will be on the top part. But I got to print all that up, and that's going to be and this is how on-the-fly engineering is working, right? So once this is done and the whole thing gets assembled, what we have is a bottom platform that has all the rotators in place where the crossing rods are giving me a positive connection. We make sure everything is sitting like it's supposed to. And then after that, what we end up doing is we go to the top deck and make sure the same thing is going on between the crossing, the cross members. Because the flight deck is going to be a little bit more complex than I initially anticipated, because we're dealing with not only the flight controller, but its power supply, the GPS. Basically, I want to try to use some other peripherals, like speed sensors, air pressure sensors, those kind of things. Because I'm going to be running the Maytech board flight controller. I think it's the H743. And I'm going to be running drone can, which is something I've not done before. But in order to push these 7070 motors, these are 75 volts. So we're running 4 120 amp MAD components ESCs that are 18S. The batteries that I'm going to run on this are 3 10,000 milliamp Z batteries, Z brand, at 120 C discharge rate. Obviously in series, so that they are 18S. The power distribution for this is completely different. It's basically going to be a bus bar with a common ground to the flight controller. You also have the whole lighting system, which is going to be powered by this buck converter, and I have to install another buck converter, but the whole thing is going to light up. So you've got your internal body parts that are going to light up. You've got the engines that are going to light up, internal and external lights. There's basically 1,440 LEDs in this entire drone. And while this is a multi-role drone, multi-role platform, this particular role is for an unveiling, right? A maiden flight. So we wanted to give it some color. And we wanted to make sure that it looked good in the air at dusk when I take off. So, fingers crossed on that day, right? So get off there, ant. All right, so let's get back to work on that. Let me check out the chat real quick, figure out which rods I got to cut next. Which I think are going to be the same one at 24 inches. So, Russell, hi, how you doing? Toxic Duo, how you doing? Welcome to it. Hope everyone's enjoying so far. We got some more rods to cut. So what we're going to do is I'm going over here to measure. I got 2 across the bottom I have to measure. Those will be 24. And then there's 2 more across the top, I believe. So, yeah, so we got, these are coming off the printer. So I got more of these coming off for this. Because I ended up needing more. Those are 20. Those were 24? Yeah, those were 24. We're doing 24. So you obviously got to mark out more at 24. 2 more this way. And then we've got 2 this way we have to do. So we're going to do a total of 4 more at 24 inches. So let's get that cut. Let's double check the measurement. Measure twice, cut once. All right, get that one marked. We'll mark this one. And then I think what we're going to do is we're going to go ahead and cut all 4. So right now I'm just getting everything measured and marked. Whew. All right. Let me check my printer and see if it's almost done. Where are we at on the printer? 1 hour. Okay, so it's saying 1 hour on that. So I printed up 10 more of those. I didn't know if I needed 10 more, but I figured might as well have extra. Because this isn't going to be the only version of this drone. We're going to do more. It's just my manufacturing processes may change. I may print a piece and then decide to mold it or turn it into a mold so that we could pour some kind of resin or some kind of, and do an injection mold or something like that. If a company wants to come in and say, hey, we can injection mold a lot of this stuff and we can CNC this and we can CNC that, ultimately is the goal. Because the projected thrust for this thing is outrageous. So, check on chat real quick. And then I'll get to cutting some more. Because this is going to be fun. Whew, gotta have coffee. Oh, you gotta have that coffee. Who all has printers? I was saying that I got the A1 combo, but that's not my only printers. I have 3KC1. What's the KC? What's the 3K1C and K2? Are those the Creality versions of what's? Just curious. Because if those are the Creality versions, I've always been curious on how good they are. Yeah, okay. How do they compare to the A1? I mean, you obviously have the A1. I assume. Okay. Does it have the same kind of like LiDAR sensors and things like that the bambulabs do? Or, because I haven't tried one yet. I haven't tried anything except the Bamboo X1 carbon. I had an Ender 3 I used before, but after the Ender 3 I went like right to the X1 carbon. And that was like somebody dropped off a Bentley at my house. You know, especially going from an A1. I mean, not an A1, but an Ender 3. So the K2 does have the LiDAR, everything else. Is it just as fast as the X1? All right, so what we're going to do next, I got to get my lovely respirator back on, because we're just going to cut the remaining 4. We're going to get them fitted. Dang. We'll slow down the work a little bit. So you got to watch me cut longer. Because I've got a little bit of time before the rest of those adapters that I made come off of the printer. And I've got to knock out some of the pegs that I have in the older ones that I made. Because after this, we are basically, like I said before, after all these rods are finished, I've got a long set epoxy. It's a, forget what brand. I'll show you the brand when we get to that point, but we're gonna have to assemble this drone. The first half was easy to put together because over on that side, the only thing I had to deal with on the opposing side is I couldn't put those two together and fit them the same way. And the reason for that is because you have crossing bars that go in. So one section has to go in at a time this way and then this way. And then at that point, since everything has room inside the tubes to shimmy back and forth a few inches, I can pull them out and I can put the resin on them, put them back in, do it on the other side. And then after all that, everything under there that's supporting those rods is going to be fiberglass taped. So, without further ado, I gotta do some more cutting. So it's about the same speed almost, but the X1 you still think is faster. I can tell you after using it, I don't want another printer. Just a better version of that one. And this is the part that gets me. They have an H2D and then the H1S, which is basically the same size printer. It's just one's 2 print heads, the other one is 1. And I was like, well, I'm not changing filament that much with this type of prototyping. Oh, you just picked up another A1. That's cool. I'm not really into switching filaments that much. If I get, I'll use my X1 if I'm going to do that, and a collection of AMSs. If I'm going to actually switch printers, so, or if I'm going to switch filaments, I should say, consistently. But I don't usually because I'm doing stuff like this. So I would love to have the S one with the bigger print bed, because that'd make things a lot easier for me. But until then, I'll do what I have to. Ugh, this respirator is going to kill me. All right, let's do this again, shall we? Giggity. All right, let's see here. Prepare for some more noise. Another seat. This better be good. All right. Well, this part might be boring for some people, but we are assembling this today. Get out of the way. All right. Square. This is how it ends for me. Leg cramp. Damn it. strip something out in there. All right, hold on. All right. It's left me no choice. Yeah, that is dangerous. I don't think I have a bandsaw. It's a good question. But I do have a skill saw. All right, I may have to step out into the backyard over there to do this. So, bear with me. I'm gonna rip through these other two. This will probably be even more dangerous. Don't go anywhere, be right back. All right, that should do it. All right. Now, where's my Dremel? I need my Dremel. Oh, here it is. Okay. Okay. Whew. Oh my goodness. Oh, that was fun. You know, here in Cali, it's still a little warm. conductive dust everywhere. It's a good point. Spray some potassium nitrate in the air, see what happens. Whew. This has been a pain, but enjoyable. That's the whole thing. Only because I'm, like, you know, getting older and I have back issues. Thanks to the military. But I got a ruptured disc. So, disc, YouTube, disc. Yeah, in my lower lumbar, so that's always fun. So your back muscles want to compensate when you're leaning over stuff to, like what I have to do here. So, just having some coffee. Hope everyone's enjoying it so far. Yeah, it has happened to the best of us. Yeah, I tell you. All right, so the skill saw was quicker. BDN 707. Hi, how you doing? I apologize if I don't get to the chat as quickly as I hoped because of how I'm having to do this. So we're gonna kind of move over a little bit so you guys can kind of see the rest of the drone. I can move this tablet out of the way. It's not gonna do me any good. Well, first off, this is toast. I gotta get another end for that. This, go up here. I need those. These are little TPU wedges that I made to make sure that everything kind of level. So now, let's check something here. All right. Whew. Okay. So we have 2 of these done. See, that's what I want right there. I want to know the highest point when these 2 come together. This is a 26. 26. So yeah, it'll be a little bit longer than I need, but that's okay. More stability. Well, I might actually have to cut some of it off. Oh no, these are for... Never mind. These are going to be for this bottom side here on the rotators. So, well, let's see. It lays down on those. That's perfect. That works. If it ends up... Okay. That's what I want right there. That's why I'm printing more of these right now. Because they'll get epoxied into place. And then they'll help me fit everything together. Oh yeah. That's what we're talking about. Okay. So I can move them back and forth. Easy enough. So, and then these look like they're going to have to be a little bit shorter. So we need one for down here. So we want to make sure, yeah, it goes above that. And when it comes together, you're looking at a lot of overlap. So these we're 24. We're going to take them down to get out here. 22. And let's do this. We know how this is going to fit together, so let's get this started, and we'll see how much longer the other ones are going to have to be. Push that together, twist that in. Okay. Yeah, that's perfect. And these will go over the top, rotate right against it, which is exactly what I wanted. And these will be rotated up, so we'll have a decent gap here for the battery bay. Okay, so these top ones, I'm wondering, no, I wanted these on top to rotate into. Because if they're down here, then I don't have a lot of distance between here and here. And initially I was supposed to have a belly pan for the battery system, so that's what I'm trying to work out here. So we're going to take, we're going to go to here, and we're going to say, right there. This one, measure this up. Okay. So I'll go rip those off real quick. Yeah. And then once these, I've got these 4 more of these rotators I gotta have come off the board. Actually, 6 more at a minimum. So, and they're almost done. That's good. And then we push everything together after all of them are in. Then first thing we do is we get everything epoxy. Gotta mix the epoxy. It's gonna be thin for a little while, which is good because it's gonna go on these pegs, in these holes, in these seams, that kind of thing. And then on all of the inserts that goes into the body frame. So that's working better than I thought, actually. And then afterwards, all of this is going to get fiberglass taped all the way against the body. So everything against the body that goes up to the body itself. And that's to kind of unify the frame between the engine mount and the body. So I'm not just relying on PETG to hold it in place. I'm actually using fiberglass tape and epoxy to make sure that that rigidity is there. Most of the weight in this system, 90% of the weight, is in the engines. So battery bay and control deck aren't going to be nearly as heavy as all 4 of these engines. This is a 70-pound drone. And you're like, how's that going to fly? Because the calculations that I have at 12,500 RPMs with my blade geometry is 472 pounds of thrust. So 472 pounds of lift, which gives me a thrust to weight ratio of, holy crap. Okay? Because even the F-22 Raptor fully loaded is only 0.86 thrust to weight ratio. Unloaded, it's like 1.2 to 1. That's why it has wings on a runway. So, yeah, we're looking at well over 4 times thrust to weight ratio. 5 times, maybe 6 times. I'll have to do the math, but I don't like math, so there. So right now, I'll have some more coffee. I hope you're all enjoying the show so far. Still a little warm here in Cali. It's starting to cool down. But I gotta leave that back door open. They're doing a lot of construction work out front because we're putting in a new road. Because we're building townhouses across the street. So, hopefully, according to the plans, I'm hoping to have a bigger garage. A 2-car would be nice. Instead of turning a single-car garage into a shop I can barely fit everything into. Because I've got a mill and everything else in the warehouse I can't even bring in here. Because I have the MPC&C over here, which we made, of course, 4 times bigger than it needed to be. And then we have that table. It's a custom-made table, by the way. And then, of course, we got the toolbox. But yeah, it's a lot of work. I agree with that, CG. I agree with that because that was one of my main concerns. I didn't want a lot of centralized weight because then you have when you're closer to the center axis, that the weight can distribute so much more quickly on a rotation or a bank, stuff like that, which causes the blades to have to compensate, which is the reason why we have PID, so on and so forth. You know that one. The PID loop for this one is going to be funny because you're talking about an 11-blade high-pass fan system that's running at about 12,000 RPMs, a little over that. And you're running an 18S system. How it's going to... Now, remember, I did a Shrike drone before. And this is the Ultra, obviously, because it's as big as... Well, I have to get a trailer to move it because I can't get it on my car. So... The original one I did was with 70 millimeter EDFs, and that was just to show that the concept could work properly. So if you look back on the playlist, you'll see the 70 millimeter EDF version of this that I did. And that was done with a SpeedyB flight controller and a APD 500X power bit distribution board, because you can't run those amps that those EDFs draw through the distribution board of a standard flight controller. You're going to pop the capacitors every single time. So I found a power distribution board that could put out the 500 amps, give me the 500 amps of overhead that I wanted, so nothing would overheat. And I piggybacked it on the bottom of the SpeedyB at 405. And what that did was allow me to push over 340 amps while I was running the drone and not overheat anything because the board could handle it. So the signal was the only thing going to the board. And then of course the power's from, I get 12 volts from the board to run the SpeedyB. And then at that point you have to add telemetry because you're not getting battery telemetry because it's not connected directly to the SpeedyB's power distribution board. You're going through a different one. Now there is a telemetry port that goes out from the APD 500X. And there is a telemetry pad on the SpeedyB, but it's a matter of getting it programmed in iNav to where it's reading it and giving you the proper battery, because you have 2 batteries running the system. You've got one on this one specifically. You've got one that's running the flight controller, and then one, or the 18S pack, that's running the actual motors. So on my other one, I could pull 12 volts off the power distribution board and run the SpeedyB just fine. but I had no battery indicator because I had to figure out how to program that telemetry pad, find the UART on the SpeedyV through iNav, and then enable it so I could get actual battery voltage, which is why when I did the Shrike V10 Maiden, if you look up that video, you'll see what I'm talking about. I flew on one battery for that whole video, and it flew for a decent amount of time, and you're talking about 470 millimeter EDFs. Of course, it was a 6,000 milliamp 100C graphene lipo battery. I forget the brand name. Oh, here it is, right here. This one. Yeah, here's the camera. So this is the one I did on the Shrike or the Shrike, the first V10 Maiden. So that's the one that I ran on that flight, and it actually did really well. So this one has no swelling whatsoever. I've dumped it past its limits, charged it back up. It does really good. David said hi. Hi, David. Now, I'm going to say this to everybody watching right now because you need to know this. I don't want to be one of those guys that says you got to have a channel membership to watch members-only content. But there's going to be a couple of videos that I may do members-only content, and that's just for age verification, so on and so forth. Because in the future, I'm going to probably be moving a person with this. It's sort of going to be a surprise. So, but first we're going to be doing the Maiden. But if you choose to become a member because you like the work that I'm doing, it helps me out. It helps out the channel. You share it with your friends. You can do anything you want. You can do the super stickers, the thanks, anything you want to. You're not obligated to. You don't have to spend the money. I'm still going to let everybody see everything. But when we drop when we drop somebody from this drone into a lake, which is the plan, that might be a members only thing. And there, Bob, you sent jewels. I don't know what those are. What's the jewels? Is this a new thing? Somebody explain the jewels to me. Anyone? But they keep changing stuff up so much on YouTube. I don't even know where I'm at half the time. Family jewels. David. All right. I'm going to take those two out. Those two carbon fiber rods I shortened up a little bit. I'm going to take them out. I'm going to rip them with the saw real quick because obviously you saw me just destroy my Dremel. So I need another one of those. So I'm going to rip it with the skill saw. That's not as accurate, but accurate enough considering I over-measured and over-designed the actual input holes for the carbon fiber rods so that we could move them back and forth after it's assembled. So, all right. So I'll be right back. This time I'm just going to hold my breath. It's only going to take a second. Be right back. carbon fiber. All right. All right. Ooh, it's right. It's what I wanted. Yeah. All right. Now, let's go check my printer. But first we can dry fit all this. So don't worry. I'm gonna see how much time I got left on it. Is that right? 27 minutes? Whew, 27 minutes. Okay. No. Yeah, I know what joules are. I got that. I'm saying on the chat it says somebody sent me 100 for 2 joules. I don't know what that means. And it's a little gift box. Whew, I'm winded. All right, so let's do a little bit of dry fitting. I know that sounds bad. Hold on. First, let's get this Arduino out of the way. Back up in its home. Need you up there long enough. Stay out of the way so I can epoxy. There we go. Okay. That's looking pretty good, actually. Looking good. All right. Let's pull back this here. I know. Complain. We don't have to worry about doing this yet because, well, for one, I've got 27 minutes, so we'll wait for that. And then basically we're going to dry fit it. If it all comes together like it's supposed to, then what we're going to end up doing is we're going to start mixing the epoxy and then getting everything just kind of slathered, you know. It's going to look all oily. It's going to look like a Diddy drone. A Diddy drone party. So. Smell that carbon fiber. Everyone take precautions when you're cutting carbon fiber. I know everybody knows this, but for the sake of YouTube and its finger on the red button all the time, wear a respirator, take precautions. Carbon fiber can be nasty, especially when it's airborne, especially when, you know, you're cutting without a vacuum. That's why I had the vacuum. And then the other parts I did outside. So just take precautions, be safe. Same thing with the epoxy. I've got the back door open for the epoxy, and I'm going to put on the respirator, because if I don't, I'm going to be loopy as hell when I start putting this epoxy on. Because it's happened to me before. So, while we're waiting, The assembly is a major step in the project. Yeah, it definitely is. That's for sure. Yeah, it's definitely this. Yeah, small step for man. Large leap for DIYers everywhere. Yes, you can print a drone that's 5 feet by 5 feet. As long as you have 28 kilograms of filament. A lot of patience, and you're crazy a little bit. Well, Daryl, I thank you for coming back in and checking it out. I'm glad you're here. Yes, the drone is looking pretty sick. Wait until it's all done with the lights. Because what we're doing today is just carbon fiber fitting, getting everything in, and we're getting it assembled. The whole thing's going to be doing this dance when it's all said and done. Let me see if I can drop these lights and see if you can get a better view of this. I'll give you a better view. I got a few minutes to burn because I have to actually get this stuff off the printer in like 10 minutes that I need. So, all right. Why isn't that focusing? Oh, it must be on. Yeah. It's looking pretty sick. Let me close that back door real quick. Just for the sake of seeing how this thing looks. Oh, that's going to be beautiful. That is going to be beautiful. Plus, I'm putting this is also going to be, there's going to be lights in the body that are doing the same thing. Now, I'm running it off of a buck converter and a bus bar that I put in there. So the power is actually distributed from a lithium polymer pack. And it's also powering the Arduino. So through the buck converter, I can power the Arduino and the 488 lights that are in each one of the engines, and then there'll be another 488 in the body. So it's gonna look pretty cool. Let me move that over a little bit for you so you can get a better look at it. And I'll just shut these lights off for a second. Let me check the printer because I gotta get those parts. So we're looking at 21 minutes. Is that right? I guess it is right. Okay. Let's shut that off. Now you can get a good view with no lights whatsoever of how this thing is going to run in the air. Line parts, printing parts. Dynamo project I'm working on. Really? Dynamo project. Are you posting that stuff? I'm glad you're inspired by it, because the whole point behind this drone is to go past what they said we can do, you know? I mean, everyone thinks you can't print a drone this size. And it'll never run on those high-pass fans that are printed in PETG. I mean, every single blade is printed. But if you check out some of the earlier tests that I did with those motors, you will see how much power they put out, even at 48 volts. But they're running at 75. So if you see that, if you go back and you look at the shorts, because I got 20 minutes until that stuff comes off the printer, and then I can actually start epoxying and fitting this stuff together. It'll be after that that I do the fiberglassing with the strips, and then what I'm going to end up doing is letting it set overnight, and then coming back, flipping the drone over, finishing it off, giggity. And then we're going to go in and start putting the rest of the electrical system together for the other lights. All those lights are installed, except obviously in the body, because we're still putting it together. So, yeah, I think it'd be cool to see what you're working on. I really do. I mean, you know, unless it's like hush hush, I get it, you know. I understand that. But I always love it when people come up and they say, you know what, this inspired me to try something. There was one YouTuber, and I don't remember who it was. Who was it that said I helped them get started? The weight minus the motors, probably around 60, 65, maybe 60 pounds. But like I was saying, when I heard somebody say that, you know, I helped them get their start, I think they were doing a gaming channel. That really felt good to know that I helped somebody get started on that. And I hope they're doing well. Oh, well, Daryl, this actually has 472 pounds of thrust, so a lot. Yeah, the liftoff's just the beginning, for sure. I will be, the epic event will be, now, I'm going to do all this the right way, okay? I'm not going to do it from a very high altitude, but I will be dropping an individual who is experienced. He's done skydiving before, so he knows what he's doing. He wants me to drop him into a reservoir or a lake. So we may take this to the lake, strap him up with his rig, fly him over the top of the lake, and then go to a safe altitude and drop him. That's what he wants me to do, but he's got to wear DPC floaties, you know? Yeah, see, that's the whole point, Daryl, is to build a multi-role platform. Now, in the end, obviously, we want to alloy the drive system. We want to alloy the fans. That's going to require a 5-axis CNC. So those are obviously hard to come by, especially in a shop this size and with the budget that I'm working with. The rest of the system can still be a carbon fiber or 3D printed exterior for the ductwork. But the point is, when the version of this is built for search and rescue, because I wanted to make a SAR-Ops drone, something that could do fire mitigation, something that could bring first aid to stranded hikers, something that, you know, stuff like that, people lost in the woods. I have a thermal imaging camera on it to track people that are maybe lost or look for hot spots in fires. And then have a gurney attachment so that you could lower it down. Somebody could get in, you could pull them off of a flooded area that are, you know, people stranded on a roof or something. Bring first aid and communications to people who are stranded that ground crews can't get to. That's the whole point behind this. That's the whole point. A multi-role platform. And you're thinking, how is this going to work in fire mitigation? Well, if you've ever seen those fire grenades, the ones that, not like fire grenades, but the ones that put out fires, you throw them into a burning building or a burning room, and it basically just goes off and sucks all the oxygen out of the room. Yeah, the government. But basically the idea is to, you know, be able to go in quick, low, and fast, hit the hot spots with those fire mitigation grenades, you know, like those fire extinguishing grenades. Be able to pepper an area and put out a fire, or, you know, because the other version of this, these motors aren't static. The other version of this, the motors gimbal. So they'll be able to, the whole drone will be able to go from a flat orientation to a vertical orientation and get into small areas, down alleyways, things like that. Places that other drones can't go, through tree lines, that kind of thing. And because it's ducted, you ain't gonna have to worry about hitting a prop against anything. Yeah, sort of like an amplifier extinguisher, exactly right. Except on a larger scale. So, something on a larger scale and something that can be deployable in an instant. You got a couple of these drones on standby. You're doing search and rescue. You're helping people out. You're finding out where people are that are stranded. All that kind of stuff. Yeah, basically. Ten of them can put out a fire, a train line. Yeah, yeah, I believe so. And that's really the whole idea behind this is. Oh, hold on, I gotta charge that battery. Now I am programming. I'll have a bigger battery running the actual lighting system, but I am programming different lighting sequences into this. And then I'm going to assign those sequences to the switches on my TX16X. That's the transmitter that I'm using. That's ELRS 2.4. So that's the transmitter and receiver I'm using. Maytech H743, I believe. Like I mentioned before, and then of course the 120 amp 18S ESCs from Mad Components. Those are going to take me a little bit to acquire, just because of the budget, but they'll get here. I got a couple of the motors, I'm sure, on the way, and this is the one main. I've actually used this one as a test motor, so I was debating on whether to take this one off, put it back on the test fan, because I do have a promise to keep. One viewer wants to see a simulated bird strike on one of these fans, and I have the test fan over there. And it's under the table. I just have to put it back together. So I may get that set up with this motor and just get 4 new ones before I go up. And then we'll basically set the fan up on the table like I did before when I was doing tests on that table. And we will set up the GoPro and the other camera, and I will do a live kielbasa drop just straight into the fan at full RPM. So that'll be a fun one, but it's on the list. Trust me, it's on the list. Who wouldn't want to see that, right? All right, so you guys will just bear with me. Yeah, a little bit. I gotta open that back door again. Got a few minutes for the printer. And then I'll pop those off of there. We'll get this thing started on assembly. Get everything together. Finally. So, I think what we can do. Now, this is the resin I'm using. I guess I can show you this. This resin it's very good resin. Not very expensive. Good brand. Good brand. So far, hasn't let me down. So, that's what we're going to be using. I'm going to be mixing up probably around, I want to say, maybe 80 grams at first. If I have to mix more, I'll do that. Maybe I'll do 100 grams. It just depends on, I can probably do 100 in that. And that's so I can go through and basically slather all the pieces that need to be covered. So, yeah, let's see what this holds. This will hold 250. So if I do 100, that's not going to be too much. But I think it'll be, no, I think we're going to go with, I'm going to be soaking a lot of the fiberglass tape. This is this stuff here. So I'm thinking maybe 200. We'll do 200. Now that's milliliters. So maybe we'll go with 150 at first. See how it goes. We'll do 150 on the milliliters. So that'll work. And then the scale, we go to, hell, let's get, come on, give me the units. Milliliters, there we go. It says 0. Okay. we're gonna be doing milliliters. That way there's no confusion. So 75 of one, 75 of the other. And that will give us our epoxy. And I'm gonna go check the printer really quickly, and I will be right back. You can't read it? Let me see. I probably didn't hold it up enough where you could read it. That brand. I think it's I don't know how to say it. Takimo. Takimo or something like that. Couldn't have said that in a more redneck fashion, right? Look at this. You got to get this Takimo. That'll solve all your problems right there in regards to epoxy resin. Low viscosity. Oh, man. All right, let me check the printer. Okay. 8 minutes. Somebody sing me a song. Let's do some Q&A while I'm waiting, right? So we have 8 minutes. I tried printing this last night, but the problem was it had to switch filament, and it does it automatically on the AMS for the X1 carbon. But what I've been doing to save money on the refills, because they're a little bit more expensive than the PETG I've been using, which is I'll show that brand name in a little bit. It's on a cardboard spool. The AMS doesn't like cardboard spools unless they're decent cardboard spools. Then it'll be all right. But what I've been doing is I've found the notch where they put the end of the filament into at the beginning of the roll before they start rolling it, and I basically rip off the side and I open up the bambulab refillable spools, because it's notched for that notch, because it's a standard, it's an industry standard to have that notch in the cardboard spool. So I rip off the side, I put the first half down into the center, and then I flip it over and rip off the other side of the cardboard spool, and then put the other half of the bambulab spool on there, and then I lock it down, and it works. But sometimes, because I've put that notch down in there, and that's where the filament is, the motor from the AMS doesn't have the power to pull it out, because I have it jammed against the cardboard. So that's the only downfall of that one. But I think it could be easily fixed by next time me just taking that into the spool, and when I rip off one side of the spool, just clip that end off down that's coming through, and then that'll stop it from doing that, and then it'll automatically switch spools. But it means I don't have to buy the refills from bambulab. Not that I don't like their filament, but when you're building something on a budget and it takes 28 kilograms of filament, then you have to make some exceptions. Now, the original engine is bambulab filament. The rest is a different brand. I'll show it to you. But they look similar, they work similar, and I mean, it looks good. You know, they look good. There's really no major difference. I can tell you that the off-brand filament from bambulab is a bit, it might be a bit shinier than the other filament, than the bambulab filament. The bambulab filament has more of a silky texture, And this other stuff has more of a reflective texture. So to me, that denotes the chemical makeup, which means that those fans done with that particular brand might be a little bit more brittle than the bambulab PETG. So, you know what PETG is. So, I mean, it's just the way it is. It's just, it's PET with an additive to make it anamorphic. Anamorphic, I believe. Anamorphic. Am I saying that right? Okay. Anyway, the point is, it's so that it can be extruded easily without you needing a much higher temperature. I'd love to do it in PET. I just don't know if the bambulab X1 carbon can handle PET. Yeah, you could print. I think you probably could print a spool for the cardboard. The problem is, once that stuff starts coming off of that cardboard spool, if you're not doing it right, you're going to be rewinding it for the next hour and a half to 2 hours if it comes off of there. It's just difficult. Now, if there's a way, like, basically, once you rip off one side, oh man, now you're giving me ideas. Daryl is giving me ideas, man. A way to print your own spool center for the cardboard, and a system to where you can basically punch that out without losing the filament off the spool in its configuration. So that's what we need to get past, because it's tightly wrapped around that cardboard spool. But if you do it right, you could, theoretically, knock it right off of that spool and still keep it wound. And now I'm engineering something in my head. All because of Daryl. So you know what? When I don't go to sleep at 3 a.m., Daryl, it's your fault. But that's okay. I just think anyway. Yeah, kind of a weed eater. Yeah, like that, basically. Now I'm going to cut my grass out in the backyard with some PETG and the weed eater. See how that works. What do you think? Can we print with weed eater material? And can we cut grass with PETG? That might be something we could try one of these days, right? All right, so I'll check that printer one more time. We should be pretty close to done. And then, like I said before, the ends we're pulling off are these right here. It's these little pieces that I designed for the inserts. I do have to knock some of these pins out right here. So we're going to knock those out of the old ones real quick. And because I'm going to need them for the other one. There's one. Two. That's what I was hoping to avoid. There it is, that's three. Gonna need that. Yeah. There we go. How many of these do I need? 1, 2, 3, 4, 5, 6. Oh, I better have enough of these. I'm not printing another set of those. 3. Yep, I got enough. I got enough. There we go. Now we're talking. Okay. That's it. Just break it for a good chance. All right. Yeah, that's perfect. Okay. So that's going to give me what I need. The printer should be done any second. Then we're going to pull those off of there, which will be fun because I'm just going to bring it out here and do it. Let me go check it. Oh, okay. Hot tamale. That's the professional way to do it. Alrighty. Whew. Okay. Another CG. Yes, you can. Okay. Well, which question are we answering? Are we talking about the weed eater, or are we talking about printing with weed eater string? All right. Well, let's get things back. Let's get things going again here. So. Get these in here. And that's what I'm doing is basically ta-da! So that gives us 2. We'll take this, we'll go like this, and then like this. Do as I say. Okay, there we go. I'm going to rotate it. It's in there like it's supposed to, because then we'll rotate this up. So even if this, see what I'm saying? Even if this is slightly longer than it needs to be, we'll still be able to work it through until it fits. It's supposed to. Damn it! Mine! So we need to do 2 more. Let's get everything fitted here. We know this one going here. So let's grab this one here and this one here. Oh, it's leaning against the wall. Okay. We're going to go down, but only if. All right. One here. Here. Did I bring too many? You can never have too many, right? It's all right. We'll just have some extra. Pull these out for a second. Start. They need to be a little bit longer. Need it to be, which is okay. Let's push that in there as far as it'll go. And we'll see if we have to do any more trimming. Yeah, this one's got to go in. That can move in, so that's okay. Let's see what we got going on here. It can be a bit of a pain because you got to do it all at the same time. Then I got to move everything back so that I can epoxy it. Not far, because they'll shimmy back and forth. So, but I want to make sure buggy panels line up like they're supposed to. And if it doesn't, obviously I got to pull some more in here. This one right here. That's what's doing it. Okay, that one's in. That one's down. But it's got to go in. This one up. Bring this. Okay. I knew this would be the fun part. This is the part I mentioned before that was basically destroying my back. in here. Bit of a tight fit. But it looks like just about got it. Wow, that was fun. Whew. All right, make sure this is even. Okay. Jeez. It's like, on today, let's do something impossible. That's good. Okay. Bring that out a little bit. That'll work. That like that, as far down as possible, because you want this as far up as possible. Well, holy crap. Oh, my back. Yeah, folks, that's me being old. Oh, my goodness. All right. Everybody still with me? Looks like we got things seated. Now the fun part. I'm gonna have to take about 5 minutes here. Clean up a little bit. All parts for version 2. Okay. Never mind those wires. Pay no attention to the man behind the curtain. Now is why I'm grateful for thin set epoxy. Because basically I'm going to pull this stuff back just far enough to get all that epoxied up. I can rotate everything I need to get everything to stay where it's supposed to stay. Get the epoxy on there, and then start doing some fiberglass taping around some of the joints to make sure everything stays where I need it. And that's going to start with, like for example, situations like this where this can go in a little bit more. We want to make sure that goes in there. So there's a little bit of a gap here. So we'll try and, there you go. That's how you do it. Same thing with this one. Alright. That'll be fine. That to be against there. Against there. Move it a little bit. Okay. Whew. All right. Hey, Rob. Rob the Gamer. That's a drone. That's a 5 foot by 5 foot drone. Completely 3D printed, yes. On one printer with 28 kilograms of PETG. Welcome to the show. Been a lot of work. But here in just a minute, after I grab something cool to drink. It's still warm here, Kelly. Yeah, 28. That's 28 kilograms of PETG. Under here, get these levels right. It's closed identically at the top as we do at the bottom. Just about does it. Whew. Okay. Jeez. Yeah, I can get pretty good sized planes off of. What kind of printer you got? Alrighty, guys. I'm gonna grab something to drink. I want to know what plane you got. What plane you printed? What kind of stuff are you into flying, Rob? Or is it Robe? Robe Gamer? I called you Rob. I'm sorry. I'll be right back. All right. Oh, the Ender 3? I had an Ender 3. Well, I still do. It's over here on the floor. I don't use it that much anymore. Mainly because after you print something on an X1 carbon, you're like, Ender what? Yeah, if you don't mind doing that, Gamer, that'd be cool. I'd like to see what you're making. That's why I'm doing this, you know, show everyone what I'm making. Keep the hobby going. Of course, I've taken this to an extreme, but why do it small, right? Everyone's building drones. FPV this and FPV that. No one's building the monsters. Gotta take risks. Take risks and print something new. That's the whole point. If you're not taking a risk and printing something new, you know, I mean, yeah, I get doing it for fun and doing, you know, projects, making your own drone, that kind of stuff, FPV, whatever, if that's what you're into. I don't even have FPV goggles. I wish I had FPV goggles, because then I would put an onboard VTX on here and everything else, like a DJI West. Guys got to try and call right in the middle of a stream. All right, Robe. We'll be here. So what I'm going to do now is the fun part. We're going to mix epoxy. Over there on the table. So let's go up a tad. Ugh. There we go. All right. Okay. Was that 150? 75 of each. I need the mixing panel. Gloves and respirator, I know. Oh, you know what? Well, I guess we can cut those as we go. I need to cut some fiberglass tape so I can get this going right. Let's see. Where is? Oh, there it is. Okay. Let's make sure. This is going to be the tricky part. Because what I have to do is get everything seated. I'm going to figure out how I'm going to spread this thing so I can get in there. I'm sorry. So what I'm going to do, I'm going to mix this stuff. I got to get that tape ready because I want to make sure I tape the outside here so I can keep everything together. Then we're going to slather everything in the epoxy. And then we're going to, if it drips down, it drips down. It doesn't matter. That's why I put this down on the ground. Probably should have done this before I put my gloves on. So for the next hour, we'll be looking for the end of the tape. It's somewhere. Maybe it isn't. I know it is. Oh dear. Son of a... Okay, hold on. Darling, can you find the rest of the end of this tape for me? I let the wife find the end of the tape. I can't do it with the gloves.
Do you even see it?
No, I couldn't. No, I couldn't see it. That's why I brought it to you.
I thought you could see it. You couldn't feel it. Or no, never mind.
See, you can't see it either.
It's right there.
Okay, pull some of it off there because I'm wearing gloves. Okay, just pull. There you go. Just there you go.
Okay.
Very professional. Thank you, dear.
I tried.
Well, at least you found it.
See?
There. All right. So, gotta make sure that's ready. All right. Fun part, here we come. Wait, hold on a second. We may have to remove the hat for a moment. Oh my goodness. Okay. Respirator is on, sort of. Okay. There. Doesn't work too well with a beard. Wah, 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 wah. All right. Oh, paddle. Mixing paddle. All right. Okay. $75 and $75. Oh wait. Oh my gosh, okay.
I'm going to get the outsides first. And then I'm going to tape them, make sure they don't move, make sure that they're adjusted with the levels. I'm going to come back through here and do this. I'll get to the chat in a minute. All right. Ow. Stay there, dang it. Ever so slightly. No! Oh, there it is. No! No! Hey, can you find it again? What are you laughing at?
Nothing.
Find the other end. Hold it there. Whew.
I think they come up with a better system for this thing.
Yeah.
The heck?
Yeah, find the end of it now, smart ass. Show off.
I don't think your drone is big enough.
You don't think the drone's big enough?
Needs to be a little bigger.
Does it now?
No, I don't think so. Oops. Ditch.
You cut me. Alright. Let's do it. Over there?
No. I know where some are though, if you need me to get some.
No, I just have them.
Oh, there. Is it the ones behind the phone?
Yes. Hold the tape for me. Pull some out.
Oh.
Longer!
It's splitting, look.
Ugh.
There, look.
Okay.
Okay.
Grab a good part. Okay. Ah!
How big is it? Okay, let me
There,
put my
there you go.
finger
Hold on.
there.
Grab the end.
I got
There
it.
you
Okay.
go. Okay. Get this one going.
Do you need me to stay?
Just for a moment, if you don't mind.
I do not mind. Did you say hi to Science World?
Science World! Hi! I'm trying to get to the chat. Can I hold it?
You look good in that hat, babe.
Do I?
Huh.
Hey. Well.
Oh, the dogs are gonna bark. I'm sorry.
Why?
Who knows why?
Who cares? One more. Ugh. Vivian, calm down. That's enough.
Okay. And that's the way- Where do you want me to put this?
Up there's fine.
Okay.
All right. Spread out evenly. All right. Vivian, you want to come in?
Say hi to Matt Graham.
Hello, Matt Graham. How you doing?
And then gamers or something. Do you see it?
Where? Who?
Rogue Gamer, he said I haven't done much with the project in a long time.
Oh,
You see it?
yeah. I'm doing fine. Just dying in this respirator, Matt. Trying to get this thing epoxied. Enjoy the show. Whew. Well, this is getting fun. Almost there.
Honey,
Yeah.
you have someone in chat named Rob, and he's asking what you're working on.
Just a second, Rob.
Hey Rod, welcome to it. I'm working on a 500 or 1500 millimeter by 1500 millimeter drone with 340 millimeter high pass EDF engines. So yeah, it's a big drone, 472 pounds lift. Comes in at about 65, 70 pounds for the drone weight. I'm doing epoxy resin right now. So that's why I have the mask on. I'll get back to the chat when I'm done with this stage. So just stick around, everyone. Have fun. Because now we're going to start fiberglassing joints.
A lot of work. Ugh. Just to hold our place. Whew. Almost dumped it. Okay. Hold on 1 second. Whew. All right, everyone, I'll be right back. I've got to get alcohol and water on this stuff, get it cleaned up. First thing I need to do is get the rest of this out. Be right back. Couple minutes.
Whew. All right, sorry about that, guys. I'm gonna try and read the chat here. Hey, Spider, how's it going? I think that's all we're gonna do for the epoxy part today, because I need these joints to kind of set up and the ends to set up, because then I gotta flip the drone over and do this exact same thing on the other side. So I know you're looking at that and going, why did he put fiberglass tape around those? And that's so that I can finish grind it later and then wrap it again with some cleaner cuts. But it's much easier this way, because then you can just use a Dremel, finish grind it out on the outside, and then make it nice and pretty when the joints are done. When you don't have a vacuum system that'll work around this, because it's an open part, you can't really bag the whole thing. I'm letting the joints and everything set up so that I can go back and fiberglass tape everything. That's the whole point. So there's a lot to it. There's a lot going on here. Right now I'm looking for my alcohol so I can get this stuff off my hands. I know I got it here somewhere. I need to drink something. Whew. I'm flying the camera. Oh man. That was a chore. So basically, now that all the carbon fiber rods are done, they're not done, but I've got to get everything basically set, let it cure, then flip the drone over and finish her off. Giggity. It's going to be interesting, to say the least. So I'm pretty sure that's all I can accomplish for today, but we'll do some Q&A here in a second because I've got to get my table back down. Then we'll switch the camera angle around. I do not want to get any resin. How's it look? Are they clear?
Yeah, it's a...
Did I have resin on them?
No.
What I can't find is the alcohol. I had alcohol here. I have to make sure I can get everything cleaned off. But I guess the stuff in the sink I'll just soak in some soapy water. Sorry guys, I'm looking for my alcohol so I can clean up. Do we have any in the bathroom?
No.
No? Don't want to waste any good whiskey. Hold on, guys. Let me go clean off my hands again.
Is that it over there?
Oh, wait, yeah, you're looking right at it.
Yeah.
You see, in my shop, I don't know where anything is. That's how the ADHD brain works. It's all here. I just can't see it. It's all there is to it. It is all here. Everything I need right here. And I am constantly pissed off because I can't find it. This is the way my brain works. I don't know what to do about it. Just me. It's sitting right in front of me, like right here on the table. It's like, I'll be right back. Hold on, guys, 2 minutes. All right. Well, wasn't that fun? So, let's bring the table back down. Bionic table. I don't know what song I was supposed to. Oh man, I got epoxy on my arms. Hold on. Keep staring at my drone. I'll know how much epoxy I have on my body now after I get up tomorrow and I can't move. Call me the glass man. All right. Well, so well, that was fun. 100. You know, I did a lot of CFD testing on this drone to make sure to see, you know, what were we dealing with as far as the output value on the thrust. The CFD puts it at well over 500 miles per hour if I'm doing a 90, you know, percent bank. And I'm flying. I still got that epoxy all over me. Good Lord. But at this point, this was like a major step for me because it's a matter of getting this body sturdy. I got to flip this thing over and I've got to do it again. And then it is a prototype. I don't expect the full force of thrust out of the PETG blades. I do know that it pulled a lot of force. That's for sure. It did a lot, actually. To the point where I almost broke chains. 2 small chains that was holding it to the table. It bent the links open. They're not heavy-duty chains. But they're friggin' metal chains. I mean, come on. So, and you have to remember, I was testing all those tests that you'll see if you go into the playlist and you go back and look. Is all you know, static thrust tests at 48 volts, and the actual thrust that we're going to get out of this is roughly, you know, 400 pounds over the weight of the drone, and you're looking at 75 volts on the motors. 48 volts was for structural testing. Everything worked good. Very torquey engine. Really wanted to move. And at 12,000 RPMs, we have max thrust. We're not going to get, you know, we're not going to push it to that. That's just the theoretical max is 12,580 something RPMs. So yeah, little by little. Eventually, the idea behind this body is that I made it modular enough. BDN 707, hey, how you doing? Mark Walkner, how you doing? Welcome to it. The drive shafts and the actual main fans on all 4 engines, I'm hoping to have CNC'd out of, you know, an alloy of some kind, probably 7075, maybe even an injection mold. It doesn't real. I'm not real sure which direction I'm going with it. The PETG worked great. At 5,000 RPMs, it fit together just, you know, it spun perfectly. And if you look, when you're going back over my tests, you'll see that the thing was doing some really, it was pulling torque, but that was only at 48 volts. And you have to remember, each one of these blades is friction fit into that hub. It is not glued at all. There's no glue hold those blades together. It is all friction fit, and it's held on by the back end of the shaft. Giggity. And then that goes through into a tapered roller bearing, which makes the vertical pull on the motor less, because there's a collet that engages the shaft at the end of the main shaft. Giggity. Sorry, I have to keep doing it. The motor goes in, the screw goes into the keyway, holds it in. But what I didn't want was the force of the motor, because of how much thrust we're getting out of the engine, giggity, that we didn't want to. I didn't want to exceed the maximum tolerances of the bearings that are pressed into the motor itself, and then the shaft goes flying, giggity. So the idea with the tapered roller bearing was to make sure that the main drive shaft would stay inside the main hub assembly, and that's where it would basically expend its torque. It wouldn't pull the motor straight through and ruin the motor's bearings. So less vertical pull on the main shaft, giggity. More rotational spin without overheating the motor. That's pretty much the whole reason. So, man, I'm gonna have this stuff on me forever. It's okay, it'll peel off tomorrow. Get up tomorrow and just but yeah, it's definitely been a project. I've been printing this drone for months, and all of it came off of one printer, just one, and it all came from 28 kilograms, probably more at this point, of PETG. And you're gonna love this. I printed this entire thing with one nozzle. Didn't wear out one nozzle on the bambulab X1 carbon. Hardened steel nozzle, extruder, same thing. You know, I got the high-end one just to make sure I didn't have to deal with any problems. And this thing, I printed the entire drone on one nozzle. Yep, 0.4 or 0.04 or 0.4, not 0.0. Is it 0.04 or 0.4? 0.04. You're right. It's the little things, you know. Stupid decimal. What do I think of ceramic bearings? I would try them, but at this point, using the tapered roller bearings is going to keep everything stable for the maiden. As long as this is flight worthy, all I have to do is hack the back of the shaft off of this thing, and I can drop the whole fan out of the front, and then do a CNC metal version of it, and then install it into the body. Because the longest part to print for this thing wasn't the blades and the hub and the main shaft. It was the stator, all the stator parts, the fan internal casing, the external ductwork, the body work, frame, all that. Each individual quarter panel of the body took 4 plates. Each set of ductwork that's around the engines took 6 plates to print. Each one of the stators took 5 plates. Each one of the blades took about 4 plates to print. So, and we're talking full volume printing here. And so it took a very long time to print this drone. I've been working on it for a while. From my original tests all the way down to where I'm at now, which is where we have a complete drone, and I just got to get the motors and ESCs installed, the battery, the flight control. This is the biggest part of the whole project right here. This was the most work, and there's still going to be a lot of fine detail work I'm doing on the body to make sure everything is completely and totally stable. But we are through a very, very intense part of this build, and that was me getting the carbon fiber rods to match up right, making sure everything's going to be wrapped. Yeah, I printed the stators. I printed the stator hub itself, and then like I said, there's another video out. There's a couple of build videos I've put out there already. One of the longer videos, like 36 minutes, I think. Something like that. It's got like a tealish blue kind of thumbnail. It says world's largest 3D printed drone. That's the thumbnail. And you'll see this drone on the floor in the thumbnail. That's where I went through and kind of showed how I assembled each fan, each stator, the drive system, the ductwork. And I believe I stopped that video, part 1, at, I don't even remember, like half the drone, I think it was. And I was finishing up the last 2 engines in tandem, because what I had done before, and you wound all the copper. Any videos on that? No, I didn't build the actual drive motor itself. You're never going to believe how I'm spinning this thing up. You're never going to believe it. The stators I'm talking about are the stators for the fan, the actual EDF stators. The stators on the motors that drive it, that's all already built. I don't want to get any misunderstandings on that one. We're doing a Happy New Year countdown 2026 already. Welcome to the chat. I'm all for the cold weather. But yeah, the motors, and you're gonna love this. I paired the right motor with the right ESC and developed my own power system, my own bus bar system to power it, because for the power distribution board. These are Flip Sky 7070 110 kV skateboard motors. And I'm getting 12,586 RPMs out of it at 75 volts. And it's got a lot of torque. That's why I chose the skateboard. I chose an off-road skateboard motor, because I know it's got to move a body. So if it can move a body, it can handle the torque feedback on my high pass fan. So that that was the ADHD part that said, we're not mathing this. We're going to go with what's physically known. This skateboard motor moves a person across rough terrain that weighs about 110 to 115, maybe more, at about 25, 30 miles an hour. Which means that the motor's got the torque, and if you match it up right with the right diameter fan, you get a turbine engine. Electric turbine, high pass. And that's how I designed it. So I just did it that way. And then after I was done with the blade design, I put it through CFD testing with the kV of the motor, the voltage I'm putting through it, the amps of the ESCs, everything I could think of to put into it to run the test, and we came up with 472 pounds of thrust. Now, I don't doubt it at that RPM. I'll tell you why. Because this fan at idle speed moved. I have this heavy metal table here, this welding table that I'm using for building engines on, things like that. And over there's the MPCNC with the other plane I'm building on it. This is another motor we're working on, and I'm building a different gear ratio for that, trying to get it printed. This is for smaller builds if you want to do, some Mach 1 RC aircraft. But anyway, my point is, one of those motors on the floor down there, I had it strapped to this one, and I just put it up to idle speed, and I had forgotten to chock the wheels. And it moved, it moved the whole table. It just started taking off. So I had to stop. But yeah, it's got some power. Yeah. No, I am, take it from somebody who is an engineer, because I've been, I went to Liberty University for industrial engineering, and now I'm going for aerospace. I'm going to finish that degree off. I'm sure that'll cost me another kidney. But my point is, all the math in the world did not get me to this point. There was some math involved when I was figuring thrust figures, but I went with my design in my head, and I go, how much air am I pushing? What motor do I need to push it? How do I need to cool that motor if necessary? how many volts do I need, how many RPMs for the fan design, and then I went, okay, it's pushing a lot of air, like a ton of air. You don't need a lot of RPMs with 4 340 millimeter fans. Oh, I get doubters all the time. I don't care. Like I said, go watch the Shrike. It's under Shrike Concept Drone playlist. If you look for Shrike, Shrike, just like this one, and then you look up V10, there's a small 70 millimeter EDF drone that I did with just 70 millimeter EDFs. I built that drone. They're like, nah, that won't work. It won't fly for more than, like 2 minutes. Well, I flew for almost 4 or 5, somewhere around there. So yeah, and that was a fun drone. And I had it in angle mode. I hadn't even opened it up all the way. You know how angle mode is in iNav? It cuts the RPMs down. It limits them for stabilization. If I don't put that thing in airplane mode, that thing would have been gone in a heartbeat. Especially since I'm not an acro pilot. And if I would have banked 90 and took off, it would have just, I'd never seen it again. But I kept it in angle mode, and I was being real conservative with it when I flew it. Yeah, everybody loves that drone. I'm going to do that one again, but I'm going to do it in 90 millimeter. And the reason why is because with 90 millimeter, and people don't understand, not a lot of people understand this. People in the field do, though. People in the hobby field do. If you want to build an EDF drone, go with an EDF that's going to give you the lowest KV. And if that means a bigger fan, then so be it. And the reason why is because you are not going to find a flight stack that's going to power that many amps without popping a capacitor. I know there's a guy on here. I'm not going to knock his work. He's making some pretty good stuff. I think he did a drone after I did or before. I don't know. I don't know how new he is. He did one, using PLA Aero and stuff like that. I didn't. I used straight PLA. I was going for performance with overweight design. That way I knew, like, if I could get it to perform well with unnecessary amounts of weight inside the body construction, then I knew that once it was streamlined, I wouldn't have to worry about thrust to weight ratios. So that's how I build stuff. I overdo it, and then if it works great, then I know if I do it right, it's gonna be perfect. So that's how I jumped into that one. And I saw his drones, and I was going, wow, he must be the only other person on here that's doing this. It was sometime after I had introduced the first EDF drone that I did. Now, people have done EDF drones in the past, but they thought they were impractical because of the power draw and so on and so forth. But if you engineer it properly, not to say that they weren't good engineers, they had innovative ideas, and I appreciate that. There just needs to be a certain method in how it's done. And that's how you get to the finish line. You just keep innovating, you keep trying different things. Could you have a bank of... You could have a bank of capacitors, but... are you talking about for the power supply or to handle the amps on the stack? Because the biggest problem I found was... And I saw this in the video that I saw from the other guy just recently. Because I was looking to see if anybody else was doing EDF drones. There ain't many. And if you look on YouTube, a majority of EDF drones that are fully 3D printed, or a majority of EDF drones, period, I'm the only one that's done a 70. Besides this guy who just recently did one. But he wasn't using, he was using 4S. I used 6S. And I didn't bother with the capacitors that were on the board, on the stack. So I used wings, SpeedyB F405, that kind of thing. And then I powered that board, like I said, through the power distribution board right here. This is the 500X. This is what gave me my 500 amps of power that I needed and I could hook in it, and I could, you know, go up to, I think, 60 volts on this thing. Not 60. I think it's 48. But I was running 22.2 volts. So if you're running a 22.2 volt EDF drone, you need to use this to power the ESC and power the flight controller, because it has pads on it for doing that. It has pads for power to the board. It has pads. It has 2 power inputs. It has your ESC connectors and everything here. But you can't get these commercially anymore, so I had to get an LLC so that I could order them. But now I'm gonna have to order like probably 20 of them in order to get them again. So you know how they are. And I was using these iFlight ESCs here, these 80 amp, and that's what the Shrike B10 was built on. But I wanted to scavenge all these parts off of the drone so that I could do the 90, because this will handle the 90. Because again, you can push 500 amps with this, and you can do it at 22 volts. You can do it at 48. I believe you can do it at 48 with this. I'll have to look up the specs to verify that. But I know it's not just 22.2 because it can handle 500 amps. So the guy that was doing his videos, when he was doing his drones, I watched him fly one where he popped a capacitor and it dropped out of the sky, and I thought, yeah, that was one of the first things I did when I designed a quad style drone. I had 64 millimeters and I was running 4S, but what I kept doing was blowing the capacitor off the board. And this was off of a Speedy B V3, just flight stack with its own power distribution board. It couldn't handle the amps. That's all there was to it. At 14S, you can't handle, if you're not 14S, if you're doing 4S, it's not going to be able to handle the amps. Any standard board, any standard flight controller with its own power distribution board. The higher the KV, the more amps. That's all there is to it. If you go up to, like, stupid flies, if you go up to 22.2 volts and you've got a 19 to 2200 kilovolt or motor that you're running, and that's the KV you're running, then a stack might work if it can handle the amps, but you're not going to do it with 4S. 4S requires too many amps. So that's why I decided, well, I can get a 6S90 and do another Shrike, like the 70 millimeter version, but do a 90 and get more lift out of it. It'll draw less amps. The battery will last longer. And it's still 22.2 volts. So when I do that one, that's going to be a side project I'm doing while I'm doing this one. I have a lot of side projects. Like a lot. Still got to do the Javelin. If you see the Javelin playlist, you'll see where I was going with that one. Again, those were 70 millimeters. I needed 90s because of the heat, because of the lift. That thing, I think, would have flown in airplane mode, but it was a tail sitter design to go. And the way I did it back then is basically what I did. People are trying to do VTOL stuff, right? They want to take off. They want to go this way. I wanted to take off like a drone with the plane pointed straight up, like a tail sitter, but with the 4 drone motors. And then the drone's motors would be, I would still have, I had elevons on it and rudders, but I wanted those 4 motors to be also the, to be used as thrust vectoring in plane mode. At the time, though, you couldn't really, the flight controller had to be oriented this way. So the drone would, on any other standard VTOL, you would take off from the ground like this with your wings level to the ground. I didn't do that. I was doing a tail sitter. And the reason for that is because I wanted to be able to fly forward in drone mode and then bank into flight mode. And then once I flipped it into airplane mode, it would come out of angle mode, which would open up that throttle and I could take off really, really quick. Yeah, VTOL on launch, then airplane on flight, best efficiency. Well, see, the trick I did was I wanted a tail sitter, but I wanted to be able to rotate the body around the flight controller. So I put the flight controller on a swiveling mount that was controlled by the servo that would put you into plane mode. So that instead of having to rotate all the engines and have all these servos that are rotating the engines forward, the engines stayed where they were in drone mode, and all I was doing was I was flying forward, starting it to go into a bank in drone mode, then flip into plane mode, and then you would see the elevons go down and level into plane mode. And as long as I was moving forward at the right speed, I was rotating the entire aircraft around the flight controller. And that was what made this special, because then to land, you would come in, you'd be doing a Cobra maneuver. You know, you come and do a high alpha, and then you would switch it back into drone mode and then land. And that gave me the opportunity to put double stabilizers on it, on the top and bottom, which gave me 2 rudders, 4 engines, 2 elevons, and 2 decent sized wings, and a rotating flight controller. So I'm going to redo that one. I'm going to revisit that project. If you see the Javelin, there's a Javelin playlist. I didn't get to take it out before I realized I was too far into it on the 70s, and I needed to redesign for 90s. 90s would have been fine. 90s would have done it. And I didn't print the entire thing out of PLA Aero, just the wings and the stabilizers. So, well, and the reason for that is because the battery you're running is 6,000 to 10,000 milliamps. So you want to make sure that there's, you know, you're not, the weight of the battery isn't just ripping through the PLA. Yeah, it's just a matter of instead of taking off with the the wing flight controller already in plane orientation, like you would consider, and then it rotates those motors forward. Mine was a tail sitter where the flight controller would rotate this way for drone mode, and then rotate the plane into flight mode for plane mode. So, and that would give me vector thrusting on it would use the motors and the control surfaces as thrust vectoring for controlling the plane. But the 90 millimeter Jav is going to be a little bit bigger than the first Javelin. It's going to have to be, just to accommodate the ESCs and some of the hardware. So it'll be taller than the one that you see me like experimenting with on my old table that I had sitting over there, or in my living room. Because it worked. It would take off. I was at almost 3/4 throttle. I don't want to be there on a hover. I want to be close to half or under on a stable hover. Yeah, I don't have to change the inertia. But realistically, it's a matter of the drone, regardless of whether it has wings or not, and it was a tail sitter, I could still set my bank angle at about 30-40, and then once I basically flew forward at 30-40 on that, and then I would switch to plane mode, the flight controller would rotate, the elevons would push down just like you would expect, and then it would level itself out into level flight, and it had horizon lock on it, so it would automatically level itself out, and then I'd punch it, and then basically it would lean into the flight, and then the same thing coming back. You would lean in and then land. So it was realistically a tail sitter jet, and I called it Javelin because it looked like, it may not make sense, but it looked like one of those 4-way, you know, arrowheads, the razor barbed arrowheads or whatever. It just reminded me of a Javelin, or those really dangerous toys we had back in the 80s, you know, like the lawn darts. I don't know who the hell ever came up with that one. Let's put rings on either side of the park, put people next to them, and throw heavy metal sharp objects and try to make it into the ring. Nothing can go wrong here. But you know what? That's how we grew up. Those were the days. You know. Now I don't want to insult anybody, but it's a bunch of softies. You know, working at Starbucks and then complaining about the hours. I mean, I was ripping up asbestos flooring for 12 hours a day in 112-degree weather. You know, so my first job I made $4.25 an hour, and I was making saw blades. uh, so a ring and a ring and a ring. Yeah, basically. It's almost like having a gyroscopic system that's just there to make sure the flight controller stays stable. And then once it gets into that flight position, then it locks in, and then you're airborne on, now you're working off of forward speed and lift on the wings. And then when you come back in, you're just landing. So the drone mode wasn't really meant to be flown for a long time in drone mode. It was meant to be take off, get to the right speed, flip into plane mode. Basically a jet without a runway. That's what you wanted, right? But I didn't want to do just the simple, my plane's taking off with wings level already, and now I'm going to rotate my motors. And I haven't seen one transition video where somebody's flying like that, where it was a smooth transition, where the plane didn't do something like stall or try to, So I wanted to smooth that out. I wanted to make it a different way, and that's what the Javelin 90 is going to be, after what I learned from this Javelin 70. And of course, the Shrike 90 is just going to be another drone version. And the great part about it is it's the same hardware. So I can do a Shrike 90 drone, I can do a Javelin 90, and it's the same exact setup as far as the engine placement, everything else. The only difference is the body and the control surfaces that I put on the wings for the Jav. So I could probably fly the Shrike 90 at close to a 90% bank, or a 90-degree bank, and achieve the same speeds. But with the Javelin's body around it, it gives it those aerodynamics I'm looking for, and the lift on the wings, which takes more stress off of the motors to stay airborne, and more stress off of the whole system to maintain lift, which will conserve battery life. So you think of the Shrike as basically the heart of what the Javelin is, and then you add in lift. Now you've got longer battery life because you're running a lower thrust to keep moving forward, as opposed to just a drone moving at a 90-degree bank. So it's all experimental. It's all fun. And this drone here, the Shrike Ultra, 340 millimeter drone, is probably, I don't want to say the craziest of my ideas, but it's up there. I'm not done yet. If you think drone is big, this is half the size of the one I'm going to be riding to the store. Yes, this is the guy with really big EDF fans. We just actually got through... Don't do that. We just got through doing the epoxy on the bodywork here. So, 6-seater. I wish. We're going to try it. Basically, the one I'm going to be doing is going to be about the size of a quad. Off-road quad. Which this almost is now. At 5 feet by 5 feet. It's pretty close to the size of an off-road quad. But I have to make sure that the one that I actually am making for manned flight is designed a little bit differently. This proof of concept puts me in the air and shows the platform works. Then when we alloy everything and we go with hard parts when it comes to body framing, and we streamline it, well, we want intake ducts to be covered. We want the air to come in, but we want it to come in unrestricted and freely. But we want it to go sort of like, I'm Imagine a cross between an off-road quad, a jet ski, and an EDF drone. You know, just some kind of new design that looks sleek, but incorporates the duct intake system into the body so that you get enough air in, but you don't have openings large enough to take anything. And plus, there'll be grating and stuff like that, so nothing can fly into the engines. So there's that. And that's about making part of the body a mesh screening as far as where the intakes and stuff go. So it's going to be an interesting design. Like, what are you guys talking about? Hold on a second. How do you feed such a hungry beast? Oh, this is a 18S system right now. It's basically three 10,000 milliamp 22.2 in series, and that's what's powering this right now. That's what it's going to be for the maiden flight. I do have a hydrogen system designed so that this can run for a couple hours. So that's really the idea, is to make sure that the maiden goes well, because we're looking at the same power density just for a short flight. With the batteries that I'm using, the hydrogen system will be a little bit heavier, but that's okay because we have the payload capacity for this. Yes, I'm going to use a PEM membrane type hydrogen fuel cell, and then I'm going to have room for at least 4 tanks, if not 2 to 4 tanks, depending on the size of the tanks that I use. But it's a bit of a challenge because this is a system that requires 75 volts with at the very least, 480 amps. So I can put that system together with some specific membranes that you could basically daisy chain together. But what I want to do is I want to see if a company out there will make me a custom PEM membrane for 75 volts or up to 100 volts at least 500 amps. If I can get 100 volts at 500 amps, yeah, 480 amps is what it takes. That's the max, because I'm running 4. You got to remember, I'm running 4 120 amp MAD components 18S ESCs, and the motors are 75 volts Flip Sky 110 kV motors. Yeah, it seems like it, doesn't it? The connectors I had to get for the battery, when I go from the battery to the main bus bar, literally has a fuse in it. It has fusing in it so that it doesn't pop. You know, when you get that arc pop when you plug it in on some of these drones, this connector actually has a fusing port in it to stop it from popping when I put it together. Because basically every time you plug in the battery, it's like you're arc welding. I'm not sure where I'm going to get the PEM. There were some solid state units that were out there that, like I said, that you could daisy chain together to give you the power for something, you know, that size. But I'm really looking for a custom cell. And my requirements basically are, because I want overhead, I want 100 volts max, and I want 500 amps. 100 volts and 500 amps. Or at the very least 75 volts at 100 amps, or 500 amps. 75 volts at 480 amps. So either 100 at 500 or 75 at 480. So, and I don't know of any real PEM manufacturers out there. I don't know of any fuel cell manufacturers that do custom work yet. I'm still trying to look into that. Like I said, I ran onto a couple places where they had pre-designed cells, but I don't want to have to accommodate the casings for multiple cells that I have to chain together. But I can get one cell to do it because I want room for my tanks, for the hydrogen. I want a runtime of at least an hour and a half, maybe 2. Really just depends on how aggressively you fly it. And you also want to be able to use hydrogen when you're doing the manned version, because you want, when I'm riding it, I don't want, to be limited by lithium polymer. And I know a lot of people are thinking, well, how is this going to be rideable? How is this going to be like a new thing? Well, you see a lot of people running around. There's one guy who surfs across the street on a drone that has a bunch of heavy lift motors on it and open props. But I'm sorry, if one wrong move and someone walking down the sidewalk is going to get decapitated with an open prop system like that. So I needed to design a closed system that would allow you to fly even at street level. Fly at street level and still be able to go off-road and take off over the trees if you wanted to. Obviously, there would have to be safety concerns, drogue chutes if you're above a couple hundred feet, just in case something happens. Setting a ceiling limit, that kind of thing. Hell, even like if you have like a power failure, this thing just blows out a bunch of airbags, like inflating one of those rafts, on a boat, a life raft. And eventually it's going to be a rideable system. So that's where we're at this point. So, what I'm going to end up doing at this point, let's see, using propane powered fuel cell. Couldn't find the company site anywhere. Oh man, propane would have been cool. You see, who's seen the Volanaut bike? That one kerosene thruster motorcycle thing. I don't know who the guy made something else too, and now he made this. And I don't see someone. I don't know how big this guy is, but that thing looked pretty small. I don't know if he had 1, 2, 3, or 4 kerosene turbines in it. But I'm sorry, I'm not putting a kerosene turbine that close to my junk. You know what I mean? Okay? And you're not banking in that thing. That's why you don't see him bank. Do you realize the G-forces that would be necessary in that thing to make a bank? But when you're working with a quad like this, you can gimbal the engines. See, this is just a flight test platform to make sure that's flight worthy. The next one's going to actually have gimbaling engines. So these engines won't be stationary. They can gimbal, they can move. So when you decide to go around a corner, you've got your outer engines pushing out and up, while your inner engines are keeping yourself straight on the ground. So you're turning around the corner with low G forces, and you're still able to make that corner like a bike or anything like that. LiDAR sensors and everything else will keep you at a specific level above the ground and when you're flying in ground mode, and sensors and cameras in front of you will let the computer know what terrain is coming and how to compensate for it. So this is going to be a smart system. It's not going to be just one of those things where you jump on it and hope to God you don't flip over. There's going to be an obvious, hardwired angle system in there. So you're not going to be able to go past a certain angle, because the last thing you want to do is, be a pilot on a drone in acro mode. Unless you're crazy. In which case, that version will have, full flight gear strapped in, kind of thing. Everyone's going to have to sign a waiver. If I had one day of NASA's budget, I'd be at the Kármán line already in something that I built, guaranteed. The problem with systems like this is they're building big systems. You see the flying cars, and what do you see? You see open props, you see blades, you see everything else. That's not practical for any kind of infrastructure that we have in place. That's not going to work. You need ducted systems with protected intakes. Can you imagine everybody with a flying car and there's a Black Friday sale over at Target? There'd be decapitations all over the parking lot. No, we need something that takes up nothing more than the footprint of an SUV and can still ride on the road. So you got the quad that I'm going to do so you can ride for fun. It's a personal single-person vehicle. And you have a much larger vehicle that incorporates this kind of technology for the purpose of flying when you want to. And we've got self-driving cars. Why not self-flying cars? Oh yeah, ducted fans is the only way to go. All I know is, right out that back door over there, I have basically my backyard. And because of the size of this drone, now keep something in mind. I am 6'4" and 290 pounds. This is a big drone. This is a very big drone. Now, it's just massive. And I'm telling you, it puts out the power. I even did my own heat sinks on the MPCNC. And I used a thermal paste here, and I'll bring one of them over so you can take a look at it. I got the rest of my motor mounts up here in my heat sink. So, okay. So you can see this motor, the top of the outrunner is sitting on top of this plate. And then there's the motor mount right there. Most of the heat's generated from the top of the outrunner, and it can be cooled off with these fins. So what I did is I CNC'd a cooling system, so when the motor goes on, and the shaft goes through there, giggity, that the fan blowing past this will cool off the front of the outrunner. And I use a thermal paste on there to make sure that it stays cool. In other versions, this will have Peltier circuits on there, 12 volt. The cool side's plate facing the plate all the way around. The hot side's up and has an aluminum heat sink on that so that the fan can cool that down. And then we can refrigerate this, which will keep the engine even cooler. Now the math we did on that one was with the combined heat of the motor and the combined cooling of the Peltier, you're getting a motor that at maximum RPM is only reaching 50 to 60 degrees Fahrenheit, which is awesome because we're refrigerating this heat sink. So that's the whole point. Now, without the Peltier circuits, it still blows air past the fins and gives me some cooling. Cooling I wouldn't get if I didn't have it on there. So if the motor gets warm, the fan's rotation is what's cooling it off through these fins. The heat's getting soaked up by this aluminum and cooled off by that fan. So let me unplug this phone real quick so I can kind of show you guys what's going on here. So you can kind of see over here what I'm talking about. I've got shorty fins there too. Those shorty fins help push more air past those fan blades, or past those cooling fins. So that's the design. It's upside down, obviously. Tomorrow we're going to flip this thing over. You'll get a better look at how it's going to work. I thought about putting some higher TPU feet up here, because I would like a little bit more clearance for my motor so that it doesn't hit the ground or have a hard landing, or at least the TPU ones that, you know, something thicker so it can, if it does have a rough landing, it can come off without destroying the PETG. But you know how it is, right? So that's the idea right there. That's going to be a beast. There's going to be one massive drone. It is one massive drone. It's not going to be anything. It just is. And there's 1,440 LED lights in it. Each engine has 488. Or 244, sorry. 244, 244. Wait, no. 288, 288, 288, 288. And then 288 in the body. And that's, do I still have them over here? It's these. I got the 2 more packs of these to put in. Basically addressable. You know the type. It's the WS2812E. Your standard Arduino addressable NeoPixels. There's the battery rack. 2 of the 10,000 milliamps. Motor mounts, wiring. This was my original ESC that I was using to test the motors at 48 volts. I do have an inline amp meter, so we'll be running that in the system. And this will have a GoPro on board. So it's not going to be FPV, because I work better with line of sight, especially when it comes to something this big than this experimental. So it is going to be line of sight, but we are going to have a GoPro on board because we want to see and hear everything that's going on the drone as it's flying. So if it has vibrations in one of the motors or something like that, or if it vibrates too much, and I don't see that from the ground, or if you just want to be able to see what's going on. So it'll be in wide angle, and I'll be filming the whole thing. And then the maiden is basically going to be, we're going to take off from the backyard, which is going to scare the hell out of my neighbors, because this is going to sound like a 747 taking off. It's going to be interesting. It's going to be very interesting. It's a good thing I know all the sheriffs around here. Because if I go up at night and turn on all those lights, guaranteed UFO sighting. Guaranteed. This you got to remember, I'm not playing around. I registered this with the FAA. It is a registered UAS. And I have everything I need in order so that I can do my test flights. I'm not trying to break any laws or anything like that. So I made sure, I've even got my vehicle number here. Uh-oh. Yeah. So that's my FX number for the aircraft. Now it's just a matter of finishing everything off. I'm really glad you guys stuck around this long. At least somebody thinks this is interesting and cool, right? No matter what happens on this maiden flight, if we get a smooth flight, we get a smooth flight. If we get a bumpy one, we get a bumpy one. And we know what to work on. If we get a motor that detonates, it's fine. We'll just reprint what we have to. Glue it on there. That's the fun part of all this, right? That's the fun part. Yeah, 3-mile flight visibility. Was that a question? No. I guarantee you if I go to... My max ceiling here is 400 feet before I have to get clearance from the FAA. If I go to 400 feet, I guarantee you with all the lights on this, someone's going to think it's a UFO. And then all of you who know are going to be like, nah, it's not a UFO, but I ain't telling you what it is. It's going to be fun. I hope it's on the news. Everyone seems to think the rapture's coming, so maybe I should get one of those really big, powerful flashlights and just put it on the bottom and just, fly over people and then turn the light on And then they're going to be like, you know, I wonder how many people I could get to repent with this thing. I'm sorry. I'm sorry. It's a bad joke, but I had to do it. It's just too much fun. I have too much fun with this job. I really do. And I mean, yeah, it's a job for me because I'm a retired Army and, putting what I can into this. This is why membership is available. People might not want to become members, but eventually there's going to be videos. I don't want to do that. I don't want to be that guy that says, well, you got to pay in order to watch my videos. I feel bad even suggesting it, yeah, tractor beam. But if you become a member, if you donate anything at all that way, it's just going to go into the drone. But when you see something like this flying through there, you're going to go, you know what? I helped do that. So becoming a member of this channel, it's going to open up perks. I'll get, definitely it's going to be discounts once I get it set up on the store, because there is a merch store that I have opened up for the purpose of basically promoting myself, it's, you can get shirts that say Drone Power Concepts. You can get the stubby fan mug. That's what this is. This is the stubby fan core right here. Okay, hold on. Hold on one second. Vivian, calm down. You can't eat anybody today. Calm down. All right. Sorry, I had to disarm the warehouse alarm. Has somebody going in there. Just handling business. But I'm going to be honest with you. I'm surprised more people aren't members. A lot of people get members on their channel, but I don't know what they're offering. What are they offering? What do you offer in a membership? Exclusive video content? That feels like I'm keeping stuff from people, but I want to show everybody my work and let people enjoy it. It's just weird. $1,000 helium dolls. There you go. The drone, the spotlight, and release 1,000 helium dolls. And then everyone will think it's the Rapture, since everyone's for some reason been thinking the Rapture. Like they're gonna know. And it says we're not gonna know the day or the hour. But hey, let's just ignore that. Right? The point is, yeah, bloopers for the members. There are some bloopers. There's been some bloopers. Yeah, bloopers would work, I guess. But, there's got to be something. You guys got to get something for your money, right? I can't just say, yeah, become a member and then you can only watch this video if you are. That feels like extortion. That's what it feels like. I mean, it might help, but not a lot of people are going to join because, let's be honest, I'm a guy with a beard, people waste time watching girls react to videos that they've already seen on the internet because they have a cleavage showing, and then YouTube acts like it's got morals. We can't let you show guns and do certain things with guns on the internet, but we'll go ahead and extort women. It's like, all they care about is the money for the ads. One of a kind emojis. So, I mean, it's like, I want to make some money on this, but I don't want to limit people who might be, you know, interested in watching this stuff who just can't afford a membership. It feels like, you know, I'm not like a Hollywood elite or some crap like that, or I don't have like 100,000 subscribers and stuff like that. What right do I have to charge anybody anything? You know, my goal is just to put what I get, if I get anything at all, back into this right here and keep creating content for you guys and enjoying the fact that I'm home because I served in the military. I did my time, came home. And, you know, now I'm just chilling and doing the engineering I want to do. Try and build a future somebody can work with, you know? I could pull some What are you trying to say? You're trying to say I'm fat, boy? Just kidding. I'm playing with you. No, I couldn't do that. It's just, it's like, I'll do an experiment. I've done social experiments before, where just to see how the algorithm works. And I'll bet money if I hired a Hooters girl to do the next video. There's my 1,000,000 views. I've got Patreon on there. If you look at my site, I'm on Patreon, Instagram, Facebook, Buy Me a Coffee website. And then of course there's a link to my store where you can get merch. You know, if you care about that kind of thing. When it comes to stuff like this. But sadly, I imagine no one's going to actually buy any unless they see this fly in it. Because the problem is, with some of the audiences out there where you're going to get a lot of views, where you're going to earn a lot of revenue, you got to cram something either really epic or chaotic into 15 seconds, because that's the attention span. And if you can hook them with that, then you got a video. But it just seems like there's no room for anyone who's looking for intellectual content. You know, for those people to make money. So what do? They don't do it. I'm one of the few that is trying to do it. You know, building something new and using my brain and, you know, making something cool. And there is going to be the end result of this entire project is a rideable vehicle, a flying rideable vehicle. Yes, I've seen the movie Idiocracy, and I can tell you it's one of my favorite because it's like exactly where the world's going. You know? And I believe that because I've seen it. Wasn't there a chick out there? I don't know her name. I think my wife showed me a video of it because she thought it was funny. It's yeah, it's my favorite movie. What can I say? Who was the chick who said that gravity was invented? Which, like, what was her name? I don't even know why she was on a podcast. I don't even know why she's popular. It's like the Kardashians. Who the hell are they? Why are they popular? All they did was shove a bunch of plastic in their face and in their ass. That's it. I mean, it's like, what made them popular to begin with? The only thing about any of the Jenners, you know, that shocked me was the fact that the guy I used to watch, you know, like read the back of the Wheaties box when I was 5 years old, decided he wanted to be a woman. If you're successful your entire life as an athlete, as a male, why would you want to be a woman? I don't get it. And then people say, well, I'm trans this and I'm trans that. And I don't want to insult anybody, you know, individually. I like to do it as a group. But I don't get it. It's like, if you say trans man, is that a woman going to a man? Or is it the other way around? So I can't figure it out. Because I just wear it. My shirt is pretty clear. It says, if gender confuses you, go milk a bull. I don't want to be mean to anybody who is going through that, even though I don't believe in that lifestyle. But, you know, just because I'm a white male, I'm in trouble automatically. You know, I'm the next right-wing extremist, apparently. So, yeah, it's pretty sad the way the world is right now. I mean, who was it? Trisha? Who? It was Trisha. Is that the girl you're talking about? The one that thinks that gravity was invented? That doesn't give me hope for the world. That does not give me hope for the future. If you've got somebody who's popular right now, making money off of just being painted up and shoved full of plastic, and they're popular, and the smartest thing that they think that they've said on TV or the internet is that, you know, who's that guy who invented gravity? God? I mean, what do you think? It's always been. And even the other guy that was interviewing her, who was for some reason painted up like Ronald McDonald, he was even in shock. He was like, what do you mean invented gravity? He was just as confused. It was crazy. I don't know. I'm going to keep putting out content that's hopefully entertaining, but at the same time, I hope. Yeah, you're hearing a lot. They're putting in a new road out there, so there's a lot of stuff going on outside. I'm just totally confused at how things are right now. Another CG decided to go ahead and make me switch tracks on my ADHD brain. What was I saying? Well, anyway, my point is, I don't. Oh, it was the gravity thing. I don't understand how anyone can grow up in today's world and think gravity was invented. It's just. What scares me is it's this next generation that's going to be going in for politics. They're going to be in politics. They're going to be in office. They're going to be in places of power. And we've already seen the result of this diseased thinking from what I was talking about before, about the way that they think. You know, I can do whatever I want. I can be whatever I want. Fine, be a desk lamp. I don't give a shit. Just don't expect me to know that's what you're pretending to be today. Unless you wear a damn name tag. And even then, I'm not going to use it. I'm just going to go. Can you imagine a name tag for somebody who's got all those genders? That shit'd be crazy. I wore a shirt that said straight, white, Republican male on it. And I did that as a courtesy for all the other people out there who believe that they get misgendered all the time. I wore the tag. I wore the shirt that said straight, white, Republican male. Of course, it said, how else may I piss you off today at the bottom, but that's not the point. The point is, I walk in, this old lady walks up to me. I think I'm about ready to get yelled at, and she fist bumps me. Well, yeah, that's right. I might be in California, and a lot of people think California is a blue state, but let me tell you something. It ain't. This valley's red. This valley is red. You want to get rid of the blue in this state, we need to just help the San Andreas fault line out a little bit. You know how they do like explosives to mine and stuff like that? And they crack the ground and break it up so they can, do mining, strip mining, I guess, what you call it. Let's just do that along the fault line and let the blue sink into the blue. And then California is a red state. I mean, San Francisco as a toilet needs to be flushed anyway. So, like a literal toilet. Like they have poop maps. So you're not like going down a street where there's too much fecal matter. What kind of society we live in? you know? And it's not because we don't have the money to take care of people. It's because there's a party that decided it's cool if drugs come across the border. And we already know who they are. They're the Democrats. You know, and if anybody's a Democrat here, I'm sorry. You may eventually get over it. But it's just stupid, you know. The common sense that in this world is gone. Gravitational constant. She woke up during a lecture and missed the build-up, like the apple falling part. Robe Gamer, what do you mean even me? Ten years ago, California was such a nice. It was 10 years. 10 years ago, it was nice. It definitely was. But you know what? We can solve all that by just, you know, putting a Republican into office instead of Gavin Newsom, who burned down L.A. for a fish. You know, I mean, that's what he did to save a fish. I mean, come on. No, that was the bullshit line that they gave you because they want those 15-minute cities. I ain't living in no 15-minute city. That ain't gonna happen. And we're like, oh, no one will need cars because of the emissions. The CO in the atmosphere, CO2, is 0.4%. You go below that, you kill all the plant life, and then vegans are the only thing we'll be able to eat. So, all I'm saying is the climate change agenda, all of it's BS, every single bit of it. And yes, the Earth is a globe, while we're on the subject. It's not flat. It doesn't have a Pyrex bowl over the top of it. Firmament means gilding, which means something that goes around something. That's the Hebrew translation of firmament. It's a gilding that goes around something. You know, like a globe. So yeah, the flat earthers, they get pissed. I watched some flat earth videos just for entertainment. It's funny how mad they get. And they get insulting to everybody. Instead of like bringing in the science, like, okay, prove it. And they can't prove it because you watched that Netflix special where they just kind of, right then and there, it should have been done. But no, they got to keep hanging on. You know, it's like, look, if you think, oh, not now. If you think, elaborate on what, are you talking to me? Sustainable development. Did you say we have to eat the vegans, like Soylent Green? Hey, whatever gets through tonight, I guess. You know? I mean, we start running out of food or something like that, you know. Nothing like a corn-fed vegan. Throw them on the Barbie. You know? I just don't get it. It's like, I don't understand the mentality behind it. It's like, don't eat animals, but the animals are going to eat the food you are saying that you are going to eat, which are the greens and stuff like the vegetables. You want to go vegan, but you know, in order to supply all the vegans, you got to literally kill every single life form that's on the plot of land where you plan on growing your soy. You're going to kill everything on that land so you can be vegan. Lord of the Flies, but national. Yeah, what are you going to do, right? Well, guys, I've done the epoxy for today. I am out of it. I've got to go get the rest of this epoxy off of me before it sets up. And I have a point. Holy crap, I have a point. Honey, I have a point. Somebody said I had a point. What's my point? Tell you what, these flies are pissing me off. One cow can feed 20 humans, but you need acres of land to grow vegetables. See, that's what I'm talking about. That's what I'm talking about. You know what a cow will eat? Grass, hay, stuff that's easy to grow, that'll grow on its own for the most part. But no, the vegans are like, we want to grow soy. Let's go ahead and destroy 50 acres of life and then plant our soy. See, we've saved the world. And the people driving their EVs and stuff like that and plugging into their houses. I'm being environmentally sound. I am trying to protect the environment by driving my EV, by shifting my entire carbon footprint out of sight, out of mind, somewhere else. Because that power is still produced by nuclear, coal, and everything else. You didn't get rid of your carbon footprint. You just put your big ass carbon footprints on somebody else's part of the planet. That's the only thing you did. If we moved to hydrogen, that'll do it. But we have an oil infrastructure that would take years to switch from. So change takes time. But the problem is, we don't want the wrong kind of change. Like, oh, everyone goes vegan. So then all the animals are going to eat all the greens that you are. I'm sorry. Sorry, you can't have your wheatgrass smoothie today. There's too many living animals that we could have eaten. The opposite of vegans. Pretty soon, I would imagine. If the vegans have their way, and it's only the animals that get to eat the greens, and of course the vegans. Let's say that was a law, hypothetically, that you had to be vegan. All of the animals would overpopulate, strip the world of all of its vegetation, and everyone would die. Because they wouldn't eat the only thing left, which are the animals. Nuclear is clean, yes. That's definitely true. That's definitely true. Everyone should have a radiothermal electric generator in their basement. That's all we need. We need, like, Fallout, Just nuclear powered everything. Well, RTGs don't have a lot of waste. And they last so long, by the time you have to do something with them, it'd be another generation. That's the way it works. RTGs can be made small enough. And I know everyone's worried because they're like, well, if you crack it open, you get irradiated, blah, 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 blah. Well, we're burning gasoline fuel and inhaling all the crap from it and everything. And you know how dangerous it is to get oil out of the ground. I know because I was a commercial diver for a while. And I've seen it. I've seen the dangers of drilling. Knowing that we'd have to go down and inspect drill heads, and knowing that if there was any air in that line, and it cracked, and you were anywhere near it, your whole body was getting sucked through that hole the size of a nickel. Yeah, make RTGs great again. Johnny's videos. If you don't sell that as a hat, then I will. We need a hat that says make RTGs great again. And just wear them around. And it would confuse everybody. Because they'd be like, Joy Reid to be up there on the news going, and what is this RTGs thing? Is that some kind of propaganda? Friggin', of course, You know, or Joy Behart is. I don't know what their freaking names are or something like. The only thing, you know, and then Whoopi Goldberg, she's freaking nuts now. Um, yeah, I don't know. Did I see your post, programmer? Which post? Like in the chat? I don't. Oh yeah, well, I have kind of done it all, sort of. Um, of the airplanes. Oh no, I didn't. Is it on your channel? Because I'll sub to you in a little bit here. Nice. How do I do this? Darn technology. Darling. Okay, these flies are just like multiplying. The sun sets, man, and you're in an area where there's orchards. Rogue Gamer, go on my main computer in here and find his channel and sub for me.
Okay.
So that I can watch his stuff.
Okay. Also,
okay.
Dinner's ready in like 15 minutes.
Is it already dinner time?
Yes. So we have about 15 minutes.
Well, I'm going to wrap it up here pretty soon now. Now I'm starting to get political, so eventually everyone's going to run. Except for the people who are with me on that. What? Yeah. And I've got to go in and I've got to get some of this epoxy off of me before it ends up on my new phone. Okay. So. All right. So yeah, I'll be subbed to you here pretty quick, and then I'll check that stuff out. But every once in a while I hear the splash outside. I have a tote out there where I grow tilapia. And I use the water from the tilapia to water the garden. And I have tomatoes that have grown so high into the air. It's insane. Now, here in California, cannabis is legal. You're allowed to have a plant or two if you want to do your own. And typically, I just go to a dispensary. But one year, I planted a tree, just a little seed. And I don't know what it is about the soil here and using the fish water, but that thing was taller than my house by the time I took it down. And I'm like thinking to myself, what am I going to do with all this? You know? Yeah, PPE is important. I'm going to get all this crap off me. Waiting for parts to reestablish. And it doesn't burn me or anything like that. Not a lot really harms me. I'm not sure why. I've got a bullet hole in this leg. I still have a bullet in this arm. Grenade shrapnel here. Oh, and I've been electrocuted probably a couple hundred times. When I was a kid, my grandma sold the house. I was raised by my grandma. She bought a motorhome, moved into that, but there was something wrong with the electrical. And I was getting hit by a 220 every time I touched the door handle when it was plugged in. And it was plugged in a lot. So there's a lot. There's a lot of times I woke up on the lawn or something like that, you know, just from opening the door. But it got to the point where when I knew I was getting electrocuted, because I could see my eyes kind of vibrating as I was getting electrocuted, and I was still consciously aware of that I needed to pull my hand away. So it finally got to the point where I could take a decent voltage and I knew when to let go. So, yeah, I've been electrocuted a lot. I've absorbed enough electricity to satisfy the death penalty in a couple of states, 5 times over. But yeah. So the one thing I did develop though was a phobia to static electricity. I hate it, man. And I think it was because of the anticipation. It's like now it's like I grab a door handle, I'm like, am I gonna get shocked? But yeah. Yeah, I've been electrocuted a lot. If I could have stored that energy, then I could be the battery for the drone. Static is kind of freaky because people think that it's harmless, but you get enough of it and you'll pop a full-grown living organism in a heartbeat. Static is more dangerous than normal electricity, and it builds up enough. Yeah, building PCs. Yeah, you want to be careful there. You gotta wear that grounding bracelet. You know? Make sure you don't have any static on you. Well, I gotta tell you guys, this has been fun. The drone is drying. The sun's coming through the door, and it looks like a crystalline beauty. Here, take a look. I'll show you. Isn't that a beautiful sight? A beautiful sight. Now back to the old guy. All right. Ever see 30,000 volts of static and deleted amounts? Yeah, I would think so. I would think so. I designed something using a static feedback loop. I'm not going to get into it because it's sort of proprietary technology I'm working on. But it does generate a stable electromagnetic field that is, how do I say, steerable. So I want to leave it at that. That's going to be for that'll be my members videos right there. Those will be the ones you have to pay to see, because I show that off, the feds are going to show up here. They're going to be like, why, we would like your technology, would you like some poison cranberry juice? You know, so we're not going to show that tech off yet, but you guys will see it eventually. See, if the tech isn't a surprise and all out at once, and there isn't enough people to keep me alive, so that know about it. So we gotta. That'll be something in the future. And bridge to capacitor. A little mouse comes up. That's it. This fur. Light burnt fur, like somebody lighting steel wool and swinging it in the air. It's just spark. Anyway, I'm being called in for dinner, so you guys have been great. I appreciate you stopping by. If you do decide to become a member of the channel, that's great. If you decide to donate anything, that's great. You're not obligated to. Just enjoy the videos, have a good time. I'll figure out how to build all this. That stupid fly landed right inside that. You know what? You're part of the drone now. Okay? So we're going to use your wings. Dumb fly. Anyway. You guys have been great. Wait, hold on. Can you say my name? Why would I do that? Your name is Edward. You want me to call you something? Now I'm confused. I'm totally confused. The account says Edward, and you want me to call you a different name. Can you elaborate? Hey Lambo, thanks for stopping by, man. If you're taking off, do what you gotta do. wait. Bot farm. Is that what it is? Yeah, it does sound like a bot. I said, hi, Edward. What do you want? You told me to call you a different name, and I'm not sure why. I love it when they do that. It's like, let's see what sounds we can get out of this person's voice so that we can do spam calls or whatever else. So, you know. I want to know what's going on. And you got to explain, Edward. Before I end the video, you got to explain. I got to know why you want to be called that. Oh my gosh, he's flying. Come on, you got to explain. Ugh, stare at my forehead. Yeah, you and me too, Lambo. I figured that's what it was for. I'd hate to see the dumb motherfucker go into a bank, try to steal something, my identity, and go buy a house. Go ahead and give it a shot. And let me know which bank too, because I'll let you go in there and try. I want to videotape that shit when they laugh you out of the bank. They'd be like, with your credit? There's a cardboard box in the alley. Go get settled. Yeah, but his name is Edward. Robe. His name is Edward. It's obvious because that's what it says on his account. So if he wants to be called something else, you know, pay me. Someone's identity and bought a BMW i9. They would laugh. See what? That's what I never used credit. I went into the military young, and I never really used credit. I still really don't. That's why it's low. That's why I would laugh at even when they try to steal your idea, or they spam call you, and then they ask you a question because they want you to say the confirmation word or non-confirmation word. I'm not going to say it here because we obviously have Edward in the chat. But it's amazing to me that they're trying to steal from me. I don't have anything. But if you want to waste your time trying, just let me video the thing. Let me video the whole thing. I won't even press charges. I'll be the one getting rich off the views because of how badly humiliated you are for trying to use my credit. I mean, I'm not a guy who doesn't pay his bills, but I don't have any credit because I just don't use it. and transferred you to the fraud department. All right, well, it looks like Edward isn't going to come back and say anything, which is too bad because I haven't collected trolls in a while. I think my next live I'll do troll hunting. I always loved my troll hunter lives. Hey, autocorrect hates me too, man. Especially that voice speed. You would think with as advanced as AI is, they could at least understand what the hell you're saying. You know? But I don't know. Let them go ahead and try to steal my identity. That, to me, would be hilarious. I want to see somebody waste their time trying to use my identity. First off, the military would be all over them in a heartbeat. Various three-letter agencies would have a field day with them, considering, what I had to do in the military. So, I mean, yeah, you want to mess with me, I'll have a satellite over your house taking pictures. But that's just the way of it. I had a job, I did it. Yeah, voice to text is worse. It's definitely worse. Especially when you ask a question, it goes, "Did you really mean this?" And I'm like, "Yeah, because what did you hear?" Yeah, it's horrible. It is. And look, this could go on for a while, but we'll do another live where we just do a chat and hang out too. We'll work on the drone, do the chat and hang out, and we'll continue this because it's fun. It really is. And I hope you all enjoyed it. But I'm going to be called in for dinner here pretty soon, and I gotta wrap this up. But you guys will see more updates on this drone. Trust me. And when I do a maiden, I guarantee you're all going to be there watching it. I know you're going to want to see that video. I'll be putting out shorts for updates. What I usually do is I use the shorts to update people on where I'm at, when I'm going to be doing my next long video or live in regards to this project. So please stay tuned for that. If you're new, subscribe, share it with everybody. If you want to become a member, you can become a member. Like I said, you're not going to hurt my feelings. Johnny, I appreciate that. Lambo, take it easy, man. Be careful out there with the lightning, okay? I've only been struck 3 or 4 times. But yeah, Johnny, I'll be subbing to you too, so I'll look for your channel too. So that way I can keep up with what you're doing, you can keep up with what I'm doing. And when this project's done and over with, we're moving on to something else. It's gonna be even cooler. So, all right. I appreciate everybody's support. I'm ready to end this thing. Somebody jumps in and goes, "What in the world would make you ask that question?" I just want to know. Oh, hold on. Hold on. You want to go outside? Oh, you want to go? No? Okay. I honestly don't know what in the world would make anybody ask that question. Well, what would make somebody ask that question? Anybody? Anybody know? Yes. Those were the days. So, I hope that answers somebody's question. Just curious, and if you get it. Do you get it? Yeah. Yeah, that's the interesting part about it. Hey, Rob, have a good night, man. We'll see you next time. But yeah, I mean, if you wanted to know, you know. All right, well, you've all been wonderful. I appreciate everyone that stopped by. It is time for me to go eat. So you all have a good night. I will see you again next time. And thank you for watching. Good night, everyone.